Hey, Welsh Metals here. Today we'll be talking about the rare earth metal tantalum. So there's tantalum. There's its atomic number at the bottom, elemental number at the top, and its element designation, Ta. I generally don't use the atomic numbers and only use the elemental ones. So let's have a little look. And that's tantalum there in its pure form, Canadian maple leaf bullion bar there, as you can see. Sort of a silvery grey sort of metal, as you can see. It sort of looks similar to tungsten or sort of titanium sort of look, as you can see. It's very nice. And it's worth a little bit also. This particular piece, these 1 gram ones, cost around £10 per gram. Not generally used as an investment item, but as you can see, it has been marked as such by a refinery. So it is good for alternate stacking, for alternate currency. So there's more to it. So I'll put this phone up right here. Zoom in. Focus. There we go. Now, it's a technologically critical element. It's used. This material is used for making SMD capacitors. These things here. Now, they're in pretty much everything in the modern times, so computers of pretty much every sort, including the phone that this video is being recorded on, that has some of these in an even smaller size within, helping control voltage. For example, these teeny tiny ones. These orange ones also contain tantalum. These can contain around 30 to 60% tantalum, these SMD capacitors. So if you can get a fair amount of weight of these, it's good for recovery. And due to tantalum's extremely high melting temperature of 3017 degrees, it is quite easy to separate, since it's almost impossible to melt it without special equipment such as a argon furnace or a plasma furnace, arc furnace. So you need special equipment, that's for sure, in order to melt these. Now, it's usually used as an refractory metal because its extreme density and high melting temperature is usually used in alloys for making other metals stronger and generally more useful, sometimes more valuable, depends what kind of metal is being mixed into, I suppose. Not too much this is actually used for in the modern era apart from that, and I've heard it's used in military applications for things like radio cases in tanks, believe it or not. Maybe used in some armor-piercing weaponry also, due to its extreme density and non-brittleness. It's also chemically inert, which makes it useful for chemistry. As in, it does not react with things like acid and such, not easily anyway. It needs special equipment in order to work. It usually has to be electronically refined. Apart from that, it's also used in furnaces, furnace equipment. For example, when stretched into a ultrafine wire, very thin wire, this is used in melting aluminium. As in, this is the filament that is in the furnace from aluminium smelters. So it has uses in giant furnace equipment also, due to its extreme melting temperature. There's the SMD capacitors there, surface mount devices. Those little lines there that you can see on one end, that indicates that they are capacitors. Let's have a nice look at the tantalum. Very nice. Finely made bar, as you can see. Look at that at times 60. See if we can see anything. Nothing too much difference. Only that it's extremely finely worked. This was highly likely made in a vacuum furnace with either xenon or argon gas, and it was probably press molded while in a liquid form. in a vacuum in order to get it to be that finer size and detail. So there's tantalum, good for an alternate investment material, technologically vital material in the 21st century. And it's quite nice. Well, till next time.